In this video, we're going to practice quotient rule. If you want to follow along, the links to the companion worksheets are in the description below, so let's get started. So the basic idea of quotient rule is that you have two quantities that are divided that you want to take the derivative of as a single entity, as a single function. Now, unfortunately, in a problem like this can't be simplified. If we could simplify it, we could reduce it to something like a power rule type problem. But because the denominator has two terms in it, we can't really simplify it. So, how does quotient rule work? Well, like power rule, it violates our basic intuition to say, well, take the derivative of the top, take the derivative of the bottom, and divide them. Unfortunately, quotient rule is a little bit more complicated, and there's a nice little mnemonic device that you will see a lot of people use to help you remember what quotient rule is. And that mnemonic device is low d high minus high d low over low low. The idea here is that when we talk about high, we're talking about the numerator. When we're talking about low, we're talking about the denominator. And anytime we say d, that means we're taking the derivative of what comes after that. So, following our little rhyme here, low d high minus high d low over low low, we take low, we take the denominator, that's t squared plus 1 times d high. So we're going to take the numerator and we're going to take the derivative. So that's going to be 2t minus high. So now we take the numerator, t squared minus 1, d low, so we take the derivative of the denominator, which is 2t. Now this is all over low low, so that's t squared plus 1 times t squared plus 1. Now let's simplify this a little bit. We can expand these products in the numerator, so we have 2t cubed plus 2t minus 2t cubed. Now keep in mind we have a negative here and a negative here, so that's going to resolve itself as a positive 2t all over, and we can simplify this as t squared plus 1 squared. Now the 2t cubes, they cancel, so we have 4t all over t squared plus 1 squared. And so that is our derivative using quotient rule. So let's look at one down here. Now this one can be done either with quotient rule, or we can simplify it and use power rule. And we're going to show you how to do both ways. So the first way, we'll use quotient rule. So we say low d high, so first we take x squared, d high, the derivative of the numerator is 3x squared minus 1, the plus 7 disappears because that's a constant, minus high, so we take the numerator, x cubed minus x plus 7 times d low, that's 2x, all over low low. So that's the denominator times itself. Alright, so let's simplify this. So when we expand out these two products, we're going to have 3x to the 4th minus x squared. Now remember, there's a negative out front here, so that means anything we multiply will be the opposite. So x cubed times 2x is negative 2x to the 4th. Negative x times 2x, that's going to be positive 2x squared. And then 7 times 2x minus 14x all over x to the 4th. So now let's combine like terms here. We've got 3x to the 4th plus minus 2x to the fourth, so that leaves x to the fourth, x squared plus 2x, negative x squared plus 2x squared, so we have plus x squared, and then we have minus 14x all over x to the fourth. Now, one thing that we can do to simplify this is that we can take a factor of x out of the entire numerator. So when we do that, we have x cubed plus x minus 14 in the numerator all over x to the fourth. So that leaves us with x cubed plus x minus 14 over x cubed, because we cancel out one of these x's down here with one of these. And so here, this is our derivative. Now, I said that I would simplify this so that we don't have to use quotient rule, because it's important to know when to use it, but also when you can avoid using it. So looking up here, we couldn't simplify the first one because there were multiple terms in the denominator, but here there's only one term. It's just x squared. So what we can do is we can rewrite f of x. We're not taking the derivative yet. What we're going to do is we're going to break every term and divide it by the denominator. So x cubed over x squared minus x over x squared plus 7 over x squared. So x cubed over x squared, that's just going to be x. X over x squared, that's going to simplify to 1 over x, and you can't cancel any x's out here. But if we want to take the derivative, what we're going to have to do is we're going to have to rewrite this with some negative exponents. So this is going to be x minus x to the negative first plus 7x to the negative 2. So now, using power rule, we can say that f prime equals derivative of x is 1. The derivative of negative x to the negative 1, the negative 1 comes down, so it's plus x to the negative 2. This becomes minus 14x to the negative 3. Now, how do we check to be sure if this and this are the same? Well, let's rewrite the two terms with negative exponents with positives. So x to the negative 2 is 1 over x squared. 14x to the negative 3 is 14 over x cubed. So now to combine these, we need a common denominator. So we're going to multiply the first term by x cubed over x cubed. So we have x cubed over x cubed. The second term, we're going to multiply an x over x. So we have x over x cubed minus 14 over x cubed. And so what we have is we have three fractions, each with the same denominator. So we can write that as x cubed plus x minus 14 all over x cubed. And there we go. It matches. So we could have used quotient rule, but we didn't have to. So it's good to know when you can avoid having to use quotient rule. Let's go on to the next one. So for this one, can't simplify it because we have two terms in the denominator. So quotient rule says low d high, so we take the denominator, x squared plus 1 times the derivative of the numerator, which is 4x, minus high, the derivative is just 4, minus high 4x d low, the derivative is 2x, all over low low, x squared plus 1, and that's going to end up being squared. So when we simplify this, we're going to multiply these, and we're going to multiply these. X squared times 4 is 4x squared. 1 times 4 is 4, minus 4x and 2x multiplied is 8x squared, all over x squared plus 1 squared. Now we can combine the x squareds, so we have negative 4x squared plus 4 all over x squared plus 1 squared. Now if you notice, we can factor out a negative 4 from the numerator. But unfortunately, it's not going to allow us to simplify anything, because if we take out a negative 4, we're left with x squared minus 1. Whereas in the denominator, we have x squared plus 1. So these quantities, because they're not the same, they won't cancel. So we're left with that as our derivative. So on to the next one. Here we've got sine and cosine, and so we can apply quotient rule in this case. So low d high, so denominator is 2 minus sine of x. So low d high, the derivative of the top, the 1 goes away, and it's going to be 2 times the derivative of cosine, which is negative sine. So negative 2 sine of x minus, so we have low d high minus high, the numerator, 1 plus 2 cosine of x. D low, the 2 goes away, and we want the derivative of negative sine x, which is negative cosine of x, all over the quantity 2 minus sine x squared. Now we'll expand this out. So we have 2 times negative 2 sine x, so negative 4 sine of x, plus 2 sine squared x. Remember, we're multiplying sine times sine, so it's 2 sine squared. 1 times negative cosine, but remember there's a negative out front, so plus cosine of x and plus 2 cosine squared x all over 2 minus sine of x quantity squared. Now there's one little thing we can do to simplify this, because if we remember our trig identities, sine squared plus cosine squared always equals 1. But here we have 2 sine squared and 2 cosine squared. So if one of each of these adds up to 1, then 2 of these will add up to 2. So we can collapse that down to negative 4 sine of x plus cosine of x plus 2. That's what happens with these two. Sine squared plus cosine squared equals 1. 2 sine squared plus 2 cosine squared will equal 2. So 2 minus sine of x quantity squared. And we cannot cancel this with any quantity up here, so that is our derivative. So let's go on to number 5. Now here we've got some multiplication going on along with a fraction. Now the way to make this easy on ourselves is to first multiply in the x cubed. So we have 3x cubed minus x cubed over, x minus 2. So that is our f of x. Now f of x has two parts. The first part is very straightforward. It's a very simple power rule. But this one, x cubed over x minus 2, that's going to require quotient rule. So over here, f prime of x equals 3x cubed is going to become 9x squared minus, now we apply quotient rule here. So low d high, so x minus 2 times the derivative of the top, so that's 3x squared, minus high d low, that's x cubed times 1, all over x minus 2 squared. So it's just this part that has quotient rule, not the 9x squared. But let's simplify that. 9x squared minus, so here we have x times 3x squared is 3x cubed minus 6x squared minus x cubed all over x minus 2 squared. Now when we combine our like terms here, we have 9x squared minus 3x cubed minus x cubed is 2x cubed minus 6x squared all over x minus 2 squared. Now we can simplify the top. Let's see if anything can cancel out for us. So 9x squared minus, we can take out a 2 from both of these, and we can take out an x squared. So we have 2x squared. We're left with x minus 3. So unfortunately, that doesn't cancel. We'd wish it would, but unfortunately it doesn't. So, to simplify this further, what we have to do is we have to multiply 9x squared by x minus 2 quantity squared to give us that common denominator. So 9x squared, x minus 2 squared over x minus 2 squared minus 2x squared times x minus 3 all over x minus 2 quantity squared. So moving off to the side here, now we can expand this back out to what it was before up here. First we'll expand out the x minus 2 quantity squared. So we have 9x squared times x squared minus 4x plus 4 minus the quantity 2x cubed minus 6x squared. And there's really no need ever to expand out your denominator. It's always going to be whatever your original denominator was squared. All right. So I'm just going to work this upwards. So we have 9x to the 4th minus 36x to the 3rd plus 36x squared minus 2x cubed plus 6x squared. And one more step and we've got this. So we combine our like terms. So we have 9x to the 4th. Here we have an x cubed and an x cubed. So that's minus 38x cubed plus 36 plus 6x squared makes that plus 42x squared all over x minus 2 quantity squared. So there is our final derivative. Now if your teacher is okay with you leaving it in separate form, then you could leave it like this. But if your teacher wants it as a single simplified expression, then he or she is probably going to want this. Looking ahead to number 6, here we've got a similar one where we're multiplying. Now some people say, well, do product rule and do quotient rule because it is a product, because you're multiplying, but it is also a quotient because you are dividing. What I would suggest is when you're able to eliminate one or the other. Now we're not going to be able to eliminate quotient rule because we're still dividing, and these two quantities don't cancel. But we can get rid of having to use product rule by multiplying this quantity into this fraction first. So I'm going to do that. So when we multiply, we treat this as 5s minus 2 over 1. So we multiply our numerators, 5s squared minus 2s plus 10s, 2 times 5s, and then finally minus 4, all over s plus 1. And then when we simplify that, we get 5s squared plus 8s minus 4, all over s plus 1. Now again, that's still just our basic function. We haven't taken a derivative yet. But this makes it a lot simpler because all we need is quotient rule now. So let's apply that. So low d high. So s plus 1 is our denominator. D high, the derivative of the top, is 10s plus 8 minus high, take the numerator, 5s squared plus 8s minus 4 times the derivative of the bottom, that's 1, all over the denominator, s plus 1 squared. So now what we'll do is we'll expand these two quantities. So 10s squared plus 8s plus 10s plus 8. That's all coming from here. And then from here, this is all multiplied by 1. But remember, there's a negative out front, so that distributes into everything. So minus 5s squared minus 8s plus 4 all over s plus 1 quantity squared. So now let's combine our like terms, s squared and s squared. So we have 5s squared, 8 and 10 minus 8 leaves us with plus 10s, and then 8 and 4 leave us with 12. So we have s plus 1 quantity squared. And so there is our derivative. Let's go on to the next one. Here for this one, now what we have is we have a fraction within a fraction. Now, to make this a little easier on ourselves, let's get rid of the fraction within a fraction by saying, well, this is really 2 times x to the negative first power. So now, the negative exponent reminds us that yes, there was a fraction here, but it removes the need to have to write it. So it makes it a little less complicated. Now, what we'll do is we'll find the derivative of this, and then we'll algebraically remove the fraction within a fraction. So the derivative, dy dx, so we still follow low d high minus high d low. So derivative of the top is x minus 6. Bottom is x minus 6 times the derivative of the top. The 4 goes away. The 2x minus 1. The minus 1 comes down, so it's minus 2x to the negative 2. And then we have minus high d low. So 4 plus 2x to the negative 1 times 1 all over x minus 6 squared. So now we expand the top. So we have negative 2x to the negative 1 plus 12x to the negative 2 minus 4 minus 2x to the negative 1 all over x minus 6 squared. Now the problem is that we have these negative exponents, and each of these negative exponents would represent a fraction. But to get rid of that, what we're going to do is we're going to multiply by x squared over x squared, which is equivalent to 1. But why do we do that? We do that because what that will do is that will neutralize all of these negative exponents. So the x squared will distribute onto all of these on top. So this becomes negative 2x plus 12 minus 4x squared minus 2x all over x squared times x minus 6 squared. Each time we multiplied, remember, we add our exponents. So x squared times x to the negative 1 left us with x to the first. X squared times x to the negative 2 left us with x to the 0. Goes away. So now we have no negative exponents. So now we no longer have fractions within fractions. And this is a handy way to deal with when you have quotient rule, but you have a negative exponent within it. So now what we have to do is simplify. Combine our like terms. Negative 4x squared minus 4x plus 12 all over x squared times x minus 6 squared. And on the top, we can factor out a negative 4. And we'll do that. X squared plus x minus 3 all over x squared times x minus 6 squared. And so there is our derivative. This one, number 8, because e to the x has a negative exponent, we can rewrite this as 4 over e to the x. Now, even though the numerator is a constant, we can still think of this as a quotient rule type problem. So the derivative will follow quotient rule. Low, e to the x, d high, the derivative of 4, a constant, is going to be 0. So that term will get nullified. Minus high, so that's 4, d low. Now the derivative of e to the x is just e to the x. Simple enough. And then we have e to the x squared on the bottom. So the first term, it's not even there, goes away, it's multiplied by 0. So minus 4 e to the x over e to the x quantity squared. So for the first time in this set of problems, we can actually cancel something. We can cancel e to the x with one of these e to the x's. So we have negative 4 over e to the x. And we can rewrite that as we did before, negative 4e to the negative x. So there's the answer for that one. Now for the last problem, now we have just two very generic functions, g of t and h of t. And we want to write what the derivative is. So the derivative, let's just follow the rule we've set down. Low d high, so the low, h of t, d high, so that's the derivative, g prime of t, minus high, g of t, high d low, it's h prime of t, all over low low, so that's h of t squared. And so anytime you look for a reference or in a book and you look up quotient rule, this is the rule that you will see. And so this is just the generic form of that rule for low d high minus high d low all over low low. If you liked the video, please give a thumbs up. For more videos like this, click on the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. If you want to support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.